this video, you're going to learn some basic programming principles to get you into the mindset of a programmer. I'm going to draw a parallel with the real-world example of baking to help you understand two things: why it's important to come up with a plan before starting to program, and how to choose a recipe and alter it if necessary to help you get your task done. Suppose I give you the task to bake some bread. The first step is to make sure that you understand the given task. Bake bread is a little bit vague. Here are some questions you might want to ask to clarify the task. What is the size of the loaf of bread? What flavor do you need to make? Are there any ingredients that you have to use? Is there anything you don't have that you might need to substitute? Is there a time limit for doing this? And are there any recipes that you could look up to use? Or do you have to make one up on your own? Coming up with a recipe on your own is the hardest part. But once you have a recipe to follow, putting it together shouldn't be very difficult. Here's a sample recipe. This recipe includes the following things: all the ingredients and how much you need of each, any steps that you need to do and in what order, any steps that you need to repeat, any substitutions that you're allowed to make, and any finishing touches on your product. You should approach writing your programs in an organized and structured manner. The paradigm I suggest is think, code, test, debug, and repeat. First, you think about the problem, then you'll write some code, then you will test it, you're going to debug it, and you'll repeat this cycle until you have a program that's working according to the specifications. With more complex programs, only when you've gone through this cycle a few times will you be able to call the program complete. The think step is probably the hardest and most important step of the cycle. It's equivalent to understanding what kind of baked good you're being asked to make. A large part of this step is making a plan to organize your code and making sure that you have everything you need in order to deal with any potential interactions with the user. You may want to draw out these interactions or how you might want to structure your code. When you're given a task to solve using programming, you almost always think of the task as a black box. It's helpful to draw a diagram showing any possible interactions between the program and the user. For the bread example, here's a possible black box visualization. On the left, you note any inputs into the recipe. All these ingredients are inputs into our black box, and the output is the outcome of the recipe. In this case, it's a loaf of bread. The code step is equivalent to getting your hands dirty and experimenting with different combinations of ingredients, any substitutions you might make, and any repetitive parts. For example, checking every 5 minutes if the crust is golden yellow. In this step, you implement different solutions you might have come up with during the think step. Once you have a solution implemented, you'll move on to the test step. In this step, you check to make sure that the final product matches the expectation. For example, is the baked good that you made a loaf of bread, or did you end up with a muffin? In programming, you run your program with different inputs and check to make sure that the output matches the expected output. Often, your code is not going to run correctly the first time, and that's where the debug step comes in. The debug step is equivalent to tweaking your recipe. For example, if the bread came out too salty, you reduce the amount of salt you put in next time. In programming, you debug a program to figure out which lines of code are causing incorrect behavior. In debugging, you fix any errors that might come up, or you tweak the recipe to be a little bit more efficient. After you debug your program, you might have to go back to the think step to try a different approach. If you do so, you'll code it up again, test it again, and potentially debug it again. You'll do this as many times as you need to until you have a program that meets the required specifications. If you repeated the cycle a few times, unfortunately, you might be stuck. At that point, it's probably a good idea to take a step away from programming and just take a quick break. Go outside, take a walk, watch TV, and then come back to the program to start again with fresh eyes. Often, before you write actual code, you might write pseudocode instead. Pseudocode is a mix of English and programming, so that you can implement a solution to a problem without actually having to get bogged down into the details of the Python language. For example, let's say the task was to find the area of a circle. In pseudocode, you might have 4 steps. The first is to get a radius from the user, then apply a formula, then show the result, and then repeat steps 1, 2, 3 until the user says to stop. There might be many ways to achieve a task in programming, and it's not really a bad thing to go down one path and find yourself stuck. If you do that, then you'll have a better understanding of why a particular solution didn't work. With more experience, you'll develop an intuition for when one concept is better to use than another. Any code that you write should be with the intent that somebody else will read it, including yourself, tomorrow, or even a year from now. That's why it's important to write readable code. That means two things. The first is to make sure that you use descriptive names in your programs. The second is to make sure that you add comments wherever you can. Using descriptive names means that somebody who's reading your code can quickly glance over it to understand what it's doing. Comments are used to tell other people at a high level what your code is doing. Here's an example. Don't worry that you haven't seen programming yet. It should be fairly intuitive. Let's say you have a is equal to 3.1, b is equal to 2.2, and this formula c is equal to a times b times b. Are you able to tell at a high level what this code is supposed to do? Probably not. But if we rewrite this code like this, pi is equal to 3.1, radius is equal to 2.2, circle area is equal to pi times radius times radius. The code on the right is more intuitive. It finds the area of a circle, pi r squared. This is an example of using descriptive and meaningful names in your code. Now, suppose that we have the same code as before. Pi is equal to 3.1, radius is equal to 2.2, and then we have this line here that starts with a hash. Any line starting with a hash indicates to Python that this is a comment. The example here of a bad comment is multiply pi times the radius times the radius. This comment isn't very useful because somebody who's reading the code can already tell that the line is calculating pi times radius times radius. Now, on the right, we have the same code. Pi is equal to 3.1, radius is equal to 2.2, but this time the comment is use the formula to calculate the area of a circle. This comment is a lot nicer. If somebody doesn't know how to calculate the area of a circle, this comment is telling them that this is the formula you use. In this code, comments weren't really necessary. That's because this code is too simple. Comments are very useful when they describe the rationale behind a larger chunk of code. Specifically, when you come up with some unique way to calculate or compute or implement something. A comment should really be used to describe a big idea behind your implementation, because it might not be obvious to others. Others can read your comments to get the big picture, and then if they want to, they can read your code to see exactly what calculations you're doing. In this video, I showed you the think, code, test, and debug steps by drawing a parallel with baking bread. Then, I showed you how you can make your code readable by using descriptive names and good comments whenever you can. In the next video, you're going to install a programming environment, and I'm going to introduce Python.